RADx is an AI-driven system for automated rheumatoid arthritis severity assessment from hand X-rays. Rheumatoid arthritis, or RA, is a chronic autoimmune disease characterized by progressive joint destruction. Early and precise quantification is critical to preventing permanent disability. Its clinical assessment relies on the Sharp-Van der Heide SVH score, the gold standard for quantifying structural damage, qualifying erosion, and joint space narrowing JSN scores. However, this manual process presents a formidable fine-grained visual challenge. Clinicians must detect subtle erosions and narrowing across dozens of small joints, where key pathological features often measure only a few pixels in size. This leads to significant inter-observer variability and a heavy cognitive load, creating an urgent need for precise, automated quantification. To address this, we introduce RADx, an AI-driven end-to-end diagnostic tool for hand X-ray RA severity assessment, transforming complex radiographic patterns into actionable and quantitative insights. We first introduce HandXFM, our domain-specific foundation model for hand X-rays, which learns comprehensive musculoskeletal representations by integrating semantic and structural medical knowledge through cross-modality distillation. Our system, RADx, first begins with automated pre-processing to normalize contrast and resolution across diverse radiographic sources. Using HandXFM as the core visual backbone with a Dieter head, RADx performs joint localization to detect MCP, PIP, and wrist joints. A dedicated regression head predicts joint-level joint space narrowing and erosion scores. Finally, these joint-level scores are aggregated to generate a comprehensive risk index and a structured diagnostic report. To bring these advanced models to the clinic, we have integrated our multi-stage architecture into a seamless, web-based platform. Here is how it works in practice. Our intuitive web interface allows users to initiate a new case with a simple upload or drag and drop of a high-resolution hand radiograph. Upon upload, the image is displayed on the left panel. By clicking the Run Diagnostic Model button, the right panel activates a waiting area with a progress bar, visualizing the real-time inference steps completed so far. Once processed, the left panel provides a clear visual mapping of the dip, PIP, MCP, and wrist joints. Simultaneously, the right panel generates a detailed analysis report. The platform aggregates these local assessments into a standardized SVH score, ensuring an objective diagnostic baseline. At the top of the report, a damage score index and a total SVH score are provided for an immediate global assessment. For each joint, users can access a detailed summary including erosion, JSN, and SVH scores, alongside confidence measurements and severity levels. The highest severity regions, specifically joints with the highest erosion and JSN scores, are prioritized at the top to direct clinical attention. To assist with decision-making, the system generates LLM-powered clinical interpretations, summarizing overall impressions and regional severity summaries. Crucially, patients' privacy is protected as no personal information is input into the LLM module. Only predicted scores are processed to generate the reasoning. Below the summary, users can independently verify all joint analyses. For clinical storage and comparison, reports can be exported in PDF format. Users can also click Download Crops to save all identified joint patches locally. For further transparency, the Help button provides a step-by-step guide, while the Methodology button allows users to explore our underlying architecture and grading scales. Finally, clicking New Case resets the system, ready for the next case. In summary, RADx bridges the gap between state-of-the-art computer vision and clinical rheumatology. We believe RADx sets a new standard for automated RA assessment, ultimately improving patient outcomes through earlier and more accurate intervention. Finally, we would like to express our sincere gratitude to the Canadian Institutes of Health Research, Canada Research Chairs Program, and Arthritis Society Canada for their invaluable support of this project. You can find more details and explore our research at our lab's website, phulab.org. Thank you for watching.